Okay, welcome to Chapter 5, Database Processing. If there is a second favorite chapter in this book, to me, it's database processing. I do this for a couple of reasons. One is, this is my favorite chapter for a couple of reasons. One is because databases are so vitally important, as you'll see when we get into database. I cover database a couple of times in this course. I'll talk about access and talk about a lot of database properties that you will see later on. Then you'll have a chance to see that. And I split these up. Some 243 classes, when they talk about database, they actually have you do the database cases. And I split this up on purpose. I want you to see it, experience it, answer questions about it. And then in a few more weeks, we will get into database itself and access and start working with it and doing everything. I think you'll appreciate that a little more. So let's jump into it. Study questions. What do you need to know? I think you need to understand what a database is, a relational database. I think you need to understand what a database management system is, and then we will do this. Applications, I will give you lots and lots of examples. Won't talk much about Falcon security. And then we will mention a few non-traditional database projects or systems and components that we can use. Databases are ubiquitous in commerce. Obviously, everything is a data point. And I've mentioned data and information before. So I want to tell you that what we're going to be using a database is to organize data and in order to get information out of this. So this is the third bullet, how to turn data into useful information. Well, you keep it organized and you allow information to be drawn from that. I think by the time we finish this chapter, I will probably spend a lot of time on this. I apologize up front. It may take more time than and you may need to do a couple of settings to watch this in its entirety. So the purpose of a database is to organize, and if you organize it right, then these other bullets will fall in place. But they have to be organized properly. Now, thankfully, most of the work you'll do in this class and with databases, unless you become a DBMS, a database administrator, then it will already be organized, and all you have to do is fill it in. Here's an example. This is pretty much what I would use a database for, is to keep track of your grades. Of course, Blackboard does that. Back before Blackboard, I did this, and I used a database to do it. But you can see the students are organized. If I glance to the left, I see their name is listed in alphabetical order. They have a student number, which is the unique number. It's a unique identifier for each student. Names can be the same. I've had classes before that students had exactly the same name, but of course their student number is different. Then you have homework, midterm, and everything, and you can do weighting on this right now. This is an example of a Microsoft Access database on what you can do. This is called a form. Yes, we will work with forms in this class. These are called subforms. You'll work with subforms in this class. I think by the time we get to that, you will see that it's not a lot of problems with this. So what is a database? Again, if you'll look at this looks like a spreadsheet. You have columns and you have rows and you have cells. We call something a little bit different. The columns, we call those fields, like student number, student name, homework, and everything is called a field. And then the rows are called records. And you can see that records are unique, fields are unique, and where everything comes together is a bit of information, or it's a data point. I will call those both things. And then of course you have characters in there called bytes. The hierarchy of data elements. Then you can see the bytes that go into columns, that go into rows, that go into tables. Then if you took this even further, you would go into a database. You put all this stuff right here and you put it into a database. And this is where we are right here with Microsoft Access. It's a database. Now we're going to take this even further and go into a database management system, of which a database is only one component of a database management system. The relationships among the rows. This becomes important as you start looking at these relationships. Now you have three tables in here. You have an email table, you have a student table, and you have an office table. And look how these are related. Now later on you'll be creating relationships. You won't have to design many, they'll be created for you. But all you have to do is tell the relationship what type of relationship it is and then put it into its order, and we will do that in a few weeks. But now these tables are related from the student number. And this student number, so you can see the relationship here. We'll be working with relationships later on with this. Now, what is a DBMS as opposed to a database? So when you talk about a Microsoft Access database, then you have a software component, and that component has to have something to make it work. Otherwise, it just is a nice program on a DVD or a hard drive that does nothing by itself. So the DBMS is everything else that goes with it. You can see the functions up here, and you can see what we're going to be using. Again, our DBMS will be Microsoft Access on a personal computer, which will be in front of you during this semester. Creating a database, again, you will do that, and you will do that based on creating tables, and you'll create tables in here, and then we'll relate those tables together, and we'll take information from the tables. So actually relatively simple. So the process operations, you read it, insert it, modify it, and then delete data. That processes the database. Structured query language, or SQL. This is commonly known as SQL, is called SQL. And its whole purpose is to be able to standardize and use database management systems. This may look complicated, the SQL example, but this is actually quite basic from what it used to be. It used to be code, and now thankfully it's statements that you want to do. When you add a new column to a table in Access, you're actually adding a new field. Now this is the design view, and we will work in both design view and table view. And you will see the difference in this right here. So if you're adding a new field in here, you're adding a new category, then you're putting that into a column, or you'll see how it works out when we get into that. Administering the database can be complex. Degree programs are built around database administrators. A database person would have to be knowledgeable in computer systems. Will you all have enough information to be a database administrator? No. You will not. If you had a computer science degree, it's a different story. Then you would be able to do this. But a business degree, now are there business majors that have been DBMS? Absolutely, absolutely. And some of you all may become DBS or database administrators one day, but you will have to have more knowledge of database and more knowledge of some of the systems and everything that you need. Really need some programming to go along with that, because there's quite a bit of coding to do when you start DBMS. Administration tasks develop on this, and you develop, you can see, get an idea of this, and then moving into your operations, backup, recovery, and then adapting, changing this around. So how do applications make databases more useful? Well, a database by itself doesn't do anything. You cram information in there and you set it up, but that really doesn't do anything for you except provide a repository or a place to store. What you want to do is take forms, queries, reports, and application programs out. During this semester, we will not be involved with application programs except to tell you you'll be using Access, and that's all we're going to do. We'll be doing forms, queries, and reports. The highlight of this will be the queries, and then the reports, and then forms. And I say it like that because forms are just a way to get information into the database. The output of a database are really the queries and reports, and they are worth their weight in gold. What is a query? It's a question. So if you want to know something, if you have a database, let's take a telephone directory. That's a database. So if you have a telephone directory and you want information out of this, you want to know the telephone number for John Smith, then you open up the telephone book and you look up John Smith, and you see lots of John Smiths, very common name. So you have to find where John Smith lives. Now what you're doing, you're querying that database. What we can do in Access, we can also query John Smith, but we need to know something more. If we need to know all the John Smiths, we just query John Smith and then hit enter, and then all the John Smiths for that database, they are printed to the screen, and then you have to decide on which one you want to use. So again, we will be able to do this more when we get into it. And then a report is nothing more than presenting the data. I've used lots of reports before, and you will also. We won't do much with them in here, but you will see how this works when we get into that. So here's the users, computers, organizational network, DBMS, and I told you there was a hierarchy past this, and that goes into tables, relationships, and metadata. This is the server system right here. And then there's another hierarchy above this that would become a data warehouse or a data mart, and you will see that. So back to the student report. You saw this a while ago in the design view, and here you have an output with the students, the homework, and the assignments, and what is taking place. A query example. This queries for words or phrases. You can query these right here. You can query for numbers. You can query for addresses and anything that you want to query for, and we'll do a lot of that. Browsers, forms, reports, queries, and applications. There's another model that demonstrates how to get to a database. We won't do a lot of work online. Now, real databases do a lot of online work, and you may have a database that would go out and find information. If you were a financial advisor, you would want to keep the latest stock quotes for buying and sale. And so if you have a database, you may have that updated every couple of minutes, where your database gets updated with the most current stuff from a browser to an internet. Account creation, again, we have our forms. In this form right here, you input information. SharePoint site, this is using Office 365. These are things that, and you all have heard of these probably, if you use any kind of Google Docs or anything else where you can work on collaborative skills. Let's see, let's keep moving. So how can Falcon Security benefit from a database system? I will just mention on here that depending on how they use that, there's multiple options that can be used on this. They can use Access to store. They can create a relationship diagram, and then they can keep things simple. What are non-traditional DBMS products? And you have a relational model. We're going to be using mainly relational products in here. Let's see, let's keep moving. The categories of non-traditional DBMS, and I'm not going to spend a lot of time on this because your book will ask you a couple of questions on here, but I won't spend a lot of time on this right now. These are non-traditional DBMS, and they MongoDB I've used a little bit. How hard is it? It's a new language of its own, so it's a little more difficult to use in the standard access than what we're doing in here. Will these replace the relational model? No, I don't think so, because relational models are too simplistic, and they're at the top of their curve right now. I don't know of anything that will replace these now. Maybe someday they will, but I don't know of anything that will happen that tells me that whether we're going to be doing anything any different using this right now. SQL's just too valuable. It's hierarchical in nature, and it's easy to understand, and we still use it. So how does this knowledge in this chapter help you? Hopefully you can understand the purpose of a database, and that's what I want you to know, is why you use a database. I'm not going to spend any time on this on the ethics guide, but I do want to talk about ethics as we do in every chapter. Databases have to be treated with respect, in that there's a lot of information out here that is private, information that is designed that if it's released it could hurt somebody professionally or personally. Excuse me, and you want to make sure that this works this way. Queries can reveal all kinds of patterns and trends. If you all have ever had your stuff hacked, then you know that right there, that can happen. So you need to make sure that social responsibility is taken advantage, is not taken advantage of. Facebook, if you think about that, that is a large database. Unexpected text is inserted. Your book will talk about that just a little bit. So what do you need to know about databases? And I think I've told you what I'd like you to know about it. You know what one is. You know what a DBMS is. You know what applications make databases more useful. And then non-traditional databases on that right there. So that's all I have for this chapter. Hopefully you understand a little more about databases. I didn't want to get into too much detail because we will do that quite a bit later on. So that's all I have. Good day.